Hi and welcome to my channel. In this video, I'm going to tackle the two-sum problem, and my goal with this video and a series of videos that I'm going to be releasing following this is to help you or share with you how I think through problem sets that I'm given, like technical questions that I'm given, and how I come up with a solution and go as far as writing the code to solve the problem itself. The reason I'm doing this is because I've gotten a number of people reaching out to me wanting to get better at solving technical problems and wants to know my thoughts process. So basically, this is to help you also acquire that ability to solve technical questions. And basically, this is the first video of the series, and I hope you enjoy it. As I said earlier, I'm going to tackle the question and show you exactly how to think through the problem. Then eventually we are going to write out the code. So the problem that we are considering for the first video is two-sum problem. And basically with this problem, what you are being asked to do is to find the pair of two integers or a pair of integers in an unsorted array that sum up to a given target, and it retains the indices of the pair. Basically, when you are given a technical question as such, you want to wholly understand the question. And over here, we are not just given the question, we are also giving a condition that says that you may assume that each input would have exactly one solution, and you may not use the same element twice. So personally, when I'm giving such a question, the very first thing I want to pay attention to is the condition that I'm giving. And over here, there are two conditions. The first one being, you may assume that each input would have exactly one solution. This tells me that there's exactly one solution. So as soon as I get a solution, I can return my answer. I don't need to proceed and check any other thing. Then it goes on to say you may not use the same element twice. So what that is also telling me is that if I'm given the set of values or the array of values, each element is supposed to be used once in trying to come up with my solution. But then you also have to try and understand the question itself. For technical questions, you are usually allowed to use any programming language of your choice. Hardly are you limited to it. For me, I'm going to be using Python, but you choose your favorite language or the language that you are most conversant in. Okay, so in this case, we will look at it in the form of a list. So if you are given a list with these numbers 4, 5, 1, 3. So we have 4, we have 5, 1, and 3. And the question is saying find the pair of integers that sum up to a given target. And in this case, our target is 6. If we've been given 6, just by looking at this set of numbers or list of numbers, you and I can say that 5 plus 1 will give us 6. So basically, just by looking at it, we know that 5 plus 1 is equal to 6. And what it means is that for this question, we are supposed to return the indices of the pair. So the pair that we are looking at is 5 and 1. But then our interest is to return what their indices. And if you know anything about arrays or lists, you know that indices starts from 0, 1, 2, 3. So here we are expecting that our indices that we are going to return is 1 and 2. So this is going to be our answer at the end of the day for a question like this. When you're given such a question, that's the first thing you want to try and come up with, like what does the answer look like? So you in your own way, if you look for a solution in that problem, what does it look like? That is the starting point of coming up with an answer. So let's take a look at the second one. We have 7, 4, 2, and 4. And if we look at it critically, the target is 8. We want two numbers here that will give us 8. So 7, 4, 2, and 4. You agree with me that it's only this 4 and this 4 that will add up to give us 8. So 4 plus 4 will be equal to 8. Okay, so now that we know this, we have to write the code for our program. I mean, we have to think through how will you write code for the computer to be able to solve this problem. You are looking at it at an eye level where you are able to pick the values, but then how will you make your computer identify these ones? So let's start dealing with this using the 4, 5, 1, and 3. Okay, so we are going to work with this list. Usually we call the method the brute force method. Okay, so that is when you are not looking for an optimized method, you are just looking for a method that works. So to think about a method that will work, the first thing I can think about is, why don't we take each member and add it to every member of the list? So for instance, in this list we have 4, we have 5, we have 1, we have 3. Okay, so what it means is that I can go ahead and do this. When I take 4, I'll add it to each member of this list. So 4 plus 4 is equal to 8. Then I'll go to the next one. We are looking for when two numbers give us 6. So we'll go to 4. Since I've taken 4, I want to add 4 to each of them to see if I'm going to get the result. Because this is doable with a computer. The computer can't just look at this set of numbers and choose 5 and 1. So we have to come up with an algorithm to help us achieve that. And one of the ways I'm thinking about right now is just take a number and add it to each member of that list, and let's see if we get any number which is equal to the target. So 4, we've done 4 plus 4. Now we go to 4 plus 5, which is 9. We come to 4 plus 1, which is 5. Then 4 plus 3, which is 7. So after adding all for 4, we didn't get the target. So let's move on. We'll take 5. Then we'll start 5 plus 4 is equal to 9. We do 5 plus 5 is equal to 10. Then we also go ahead and do 5 plus 1 is equal to 6. So over here we get our answer. And just as I mentioned to you, there was a condition that you may assume that each input will have exactly one solution. So if you are writing code to do this thing, one thing that your condition means or implies for you is that as soon as you get this, end it, don't continue. But let's assume that we haven't found our solution. We'd have just gone ahead and do 5 plus 3 is equal to 8. Then we'll come and pick 1. 1 plus 4, okay, is equal to 5. So we'll do that for all the numbers. And basically, all that we are doing is, when I take, for instance, the first time I took 4. So when I take the first element of this list, I add it to every single member of the list to find out if I'll get my target. Then I come and take another element, then I add it to each element in the list. So that is basically what I have been doing here. And once we've been able to come up with an algorithm, as I'll call it, that helps us solve the problem. So remember that we are doing it the brute force way. When we are done, we will then analyze how efficient our code is and see if there is a way to improve that code. But then for now, we can stick with the solution and try and convert this into code. So what we currently have is, we choose each member. Okay, so choose a member from the list. Okay, then add this member to each member of that list to see if you get the target. Then we are going to have to repeat this process till we get a target. So we get the answer. Okay, so basically that's what we are doing. If you paid attention here, we just take one member of this list, add it to every member in the whole list. Then if you don't get it, we go to the next member, add it to all the other elements in the list, and we keep repeating till we get the answer. But then there is another important thing that we need to take notes here, that we may not use the same element twice. That means that when I was discussing here, for instance, 4 plus 4 shouldn't be done. Okay, that is not acceptable. Then 5 plus 5 shouldn't be done. In the same way, 1 plus 1 will not be done, and 3 plus 3 will not be done. So that should also be in your mind. So just as I said, you would have to choose a particular programming language to code your answer in. But now that you have an idea, you can convert this idea into a pseudocode. For us to choose each member of the list, for now we know that we can do that with the help of a loop. We are going to run through the whole list. Once you are going through a cycle like that, then a loop is the best suited option for it. So whichever program that language that you are using, you can choose to use a loop. And the commonest loop for this case would be a for loop. So for instance, what we can say for choosing a member, once we have the list, okay, 4, 5, 1, and 3, that's the list we are dealing with. We can say for a member, so for a member in this list, so after we've gotten a member from this list, the next thing we'll do is we are going to add that member to each member of the list. That means that we are still going to loop through the list again to enable us add up the member that we have gotten right now. Okay, so let's say this member that we have here is called X. So for X in this list, what are we going to do? We are still going to loop through another. Okay, so for each member, let me just say for each member in the list, okay, so right now let's say I've taken 4, which is represented by my X. We are now going inside the loop again. So this is like an outer loop and this is an inner loop. So in there we are going to enable us add this to each member of this list. So for each of them, what we are going to do, assuming that each member here is being represented by Y, for each of them what we are going to do is X plus Y. So that will give us the sum that we are adding. Okay, that will give us the sum that we are looking for. All right, but then we want to compare this to the target. So we are going to check if this plus that is equal to the target that we are given, and if it is equal to, all that we are going to do is return the index of, so we are going to return index of X and index of Y. Depending on the programming language you are using, this may come up a bit different, but I believe you get the idea. You use an outer loop that will choose each of them. So when you choose 4, then you come to the inner loop that will take each of these ones. But when you are writing your code, you have to make sure that you are avoiding the use of the same element that you have selected from the outer loop, because of the condition that says you may not use the same element twice. So this is the brute force solution that I've come up with, but let me quickly go and code this solution so that you get to see exactly how it is done. All right, so let's create a new file, call it twosum.py. Since I'm using Python for this code and I want to make my script executable, so I'm just adding this line of code to make sure that I can execute my code. Now we have this and say solution to the two-sum problem. Then from the discussion that we've had so far, let's create a function in Python called twosum that will be used to solve the task. We need to pass a list to it. So let's call our list nums. Then we need a target. So we are setting two arguments to this function, the nums and target arguments, or putting them as parameters for the function that we are creating. Okay, and what we are going to do is come up with the first loop. So let me use comment, say the outer loop to get each member. Okay, and in Python we write a for loop as this. I could say for the nums in the list, okay, that is for each number in the list. But then since at the end of the day I'm interested in the index of the number, I think I want to generate the index of the number. So I'll say for I in, then to generate the index I'll have to use the range function with the length of the list. And basically all that this is doing is that give me ranges from 0 to the total, which is this, or to a number before that. So in our example, let me come down here and write something here where we have 4, then we have 5, 1, and 3, as I showed earlier. With this specific example, what is happening is that this is index 0, index 1, index 2, index 3, and the whole length is 4. So this function here, the nums will return 4. But then this range, when you say range 4, okay, when you pass the number 4 to range, what you are actually going to get is numbers from 0 to 1, 4 minus 1. So that will be 0, 1, 2, and 3. So this is basically what we are going to get with this particular loop. It means that the loop is going to start, I is going to start with 0, then I will become 1, I becomes 2, then I becomes 3. So 4 times I will have I 4 times, and that basically represents all the indices of the members of this particular list that I'm dealing with. Remember that aside the outer loop, we needed to create an inner loop that will enable us, that enables the subsequent additions. Okay, so let me say it that way, subsequent additions. And basically we can do a similar thing by just saying for and call this j in range, since we want that same list, but then there is a condition that we need to obey. In this same case, j will also begin from 0, and we don't want that situation, because if I have taken 4, I don't want to take 4 again, because there was a condition that each element should be used only once. For that matter, I have to start this particular, the range function, the starting point should be I plus 1. Okay, and basically what it means is that for I plus 1, that means when we start for the first loop where I is 4, we want to come in and add 4 to each of them, but we don't want to start from 4. So the range where we have range of I in this case is 0, so range of 0 plus 1, which is 1 to 4. What it means is that this is going to give us indices from 1, 2, and 3. Okay, so we are not going to get 0. That means at the end of the day, when we start adding, we are not going to add 4 to it. We are going to now start picking 5. So I want to do something like this. Now I'll start 4 plus 5. Then I'll go to 4 plus 1. Then I go to 4 plus 3. Then I end that inner loop, come back to the outer loop. So basically that's what I'm trying to achieve with this inner loop. And that is why I have the I plus 1 over there. Once I've gotten this, the next thing I want to do is to just add the two numbers and see if they are the same as the target. So how do I add the two numbers? Basically, let me just declare a new variable called my sum and say my sum is equal to get the each member. Remember that these I and j, because we use the range function with the length function, is giving us the indices. But if we want the actual number, then we have to use this notation, okay, to get the actual number. So the index of, so index at I, in this case, sorry, so index at I. So when we start at first, I is 0. That means that nums at index 0, which is 4. Then we add this to index at j, or nums at j, sorry, nums at j. Basically, what we have done here is I've taken 4, then when I go into the inner loop, my j is this particular location. So when I say nums of j, that is 5. I'm adding 4 and 5 and checking. So let's go ahead to do the checking. Check if, so we say if my sum is equal to the target that we are given. So in this case, we'll have to, let me call this my nums. Then we have to declare targets. The target we are given is 6. Okay, so at least when you know the problem set, it guides you in creating your function. Then I'll put some column here. If my sum is equal to target, then what? All I need to do is return. Remember that we're asked to return the indices and not just the numbers themselves. So to return the indices, I could return I and j, because I and j are indices. And basically, with this, I think we should be able to solve the problem that we have. So how do we go about to test this code? All we need to do now is let's call our function toSum, then pass the nums as we have here and our target to it. Okay, and we are going to run this code to see. All right, let me print this to see if it gives us the solution we are looking for. You and I know that the solution should be 5 and 1, and 5 is index 1 and 1 is index 2. So we are expecting the solution to be, we have 1 and 2. That is what we should expect when we run this code. So let's see if we get that same thing. Is there an error anywhere that I haven't catched? Okay, sorry. Yes, so there was an error, but it was just me leaving out this column. All right, let's bring out the terminal, make this Python script executable with the chmod condition. If you're on Windows, you wouldn't be doing this, but let me make it executable, then toSum. All right, this means that if you're on Windows, you'd have to type Python 3 before you bring the name of the file, okay? But I don't want to be doing that. That is why I've made it executable. Then I could use this, then run it. And as you can see, I'm getting 1 and 2 as the answer. And that's exactly what we expected, 1 and 2. All right, now let's change this to 2 and see if I change this to 2, you realize that we now have 4 plus 2, that will be the answer. So we expect that the answer will be 0 and 1. Okay, and basically when you come up with a solution like this, you want to try as many options, like come up with test cases to see if the solution that you have given efficiently answers the questions, or it actually answers the questions, because sometimes it's just the specific example that you have taken that gives you the right answer. You are lucky, so you have to try other possible solutions. So you can see that when I changed it as well, we got the answer. But then this is not the most efficient way to look to solve this particular problem. Why do I say so? Let me go back to the notepad. Let's go to the next page. So when you are checking for efficiency of code, there are some terminologies if you haven't learned about code efficiency. I mean, time and space complexity. If this is your first time hearing about it, then you want to go and learn it before you appreciate this. And I may do some series on it soon, but for now, let me quickly walk you through what that means with respect to this particular code. So how we came up with this solution, you realize that we had to go through the whole list one after the other. We took 4, then we went to add 4 to each member of the list. Then we came to take 5, then we went to add it to each member of the list. So in effect, we are going through this list n times with this, or so assuming there are n elements in this list, which we know right now is 4. Okay, so 4 elements. It means that we are going through this element 4 times. But for each time that we go through the elements, we still add it to each of them. So we still go through it again 4 times. So in essence, you are going through the list 4 by 4 times in order to get the solution. Okay, so at the end of the day, we have something we call the big O of the code, or the worst case of this code that you have written. Okay, and as I said, if you don't know anything about time and space complexity, it may not necessarily make sense now, but I'll do some lessons on it soon. So for now, just know that for this list that had 4 members, I had to go through it 4 times. But for each time that I went through it each of them to 4 times again. That means that I'm getting 4 by 4 times before I end up getting my list. Like I'm going through that loop over and over and over. But how many times? I'm doing it 4 times times 4 times. Okay, so in big O notation, we say n times n, and which will be represented as n squared. So it is written as big O of n squared. And this is not good at all. There should be a way to optimize it for us to get anything less than going through it over and over and over. Can't there be a possible solution that we don't need to go through over and over? So now that you've come up with a brute force solution, which isn't like the most efficient method, then you'd have to think through it and see which other method can I use to solve this problem, or how can I optimize this solution after I've chosen the element. So I'm going to share with you the an optimized solution that I came up with. So we're still working with our list, which is 4, 5, 1, and 3. Now, if I take 4, do I necessarily have to add it to each of them before I know which of them will add to 6? Because 6 is my target. Remember that 6 is my target. When you think critically through it, you realize that when you take 4, what do you need to get 6? Obviously, you need to add 2 to 4 to get 6. So instead of me going through the list to add each of them to find out if I'll get the pair that adds up to 6, why not look for that pair, then look inside my list and see if it is there? So what I'm saying here is that now when I pick 4, I'm not going to add 4 to all of them. All I need to know is 4, 6 minus 4, what will it give me? 2. That's 2. So I ask myself, does 2 exist in this list? If no, let me go to the next number, pick 5. What number do I need to add to 5 to get 6? Or 6 minus 5 will be what? 1. So does 1 exist in the list that I have? Yes, if yes, then I found my answer. So my answer is 5 and 1, and I need to return their indices. So this is index 1 and index 2. As simple as that. So it looks, as you can see, this particular solution looks more optimized, and we are not doing that double running where you take one number, then you add it to all of them. Okay. So at the end of the day, with this one, all we are doing is we are going to go through our list. Okay, so let's assume that we have something like okay, so in the same way, when we took 5, okay, 4, 5, 2, and 1, or in the worst case, okay, if we don't get our number first, what is going to happen? Sorry, this was 1 and this was 3. We will take this, add it to, we take 4, then find if 4 has an additional number to give us 6. Then if that doesn't work, we take 5 and find the additional number that will give us 6. If it doesn't work, we take 1 and do same to it, we take 4. So in simple things, I'm just trying to summarize this efficiency checking thing for you. So in simple things, what is happening is that we are going through it only 4 times. This time around, we are not doing it 4 times 4, okay? So at the end of the day, it's just 4 times, or basically n times. So we can say that this is big O of n, which is way better than the n squared. So this solution is a bit optimized. Let's go into the code. Let me write out that particular solution. So if it works fine, it should give us the same answer as the one that we created initially. Okay, so let me say def then 2 sums pro, let's call it this way. Then it will also take the nums list, then we'll pass a target to it. In here, let's see what we are going to do. All right, you know that we need a loop, so let's call a for loop. And since we are going to be returning the indices, it only makes sense for us to target the indices. So I'll use for I in range, then len of list, which is nums. Then once we have this, okay, we have, let's say in this our case, we have 4, or the index of 4, what do? We are looking for a target value, or we are looking for a value that will add up to 4 to give us 6, which is our target. So what we can do now is find that expected value. So let's create a variable called expected value, or better still, I can say expected index, since we are dealing with index right now. Okay, or okay, you let me make it expected value, and it will be easy for you to understand. So with the expected value, we know our target, which is 6 for the example that we have, minus 6 minus this specific value that we have taken, which is nums at index I. So when we took the very first one, which is index 0, then we are dealing with 4. So 6 minus 4 will give us 2. So the expected value is 2 in this case. Then after we have gotten this value 2, what we need to do is check if this value, okay, this expected value, okay, so let me just say check if the expected value exists in the list. That's what we need to check. But then, depending on the programming language that you are using, it may be tackled differently. So if it is in here, I'm using Python. So with Python, how I'm going to go about it is using a method called .index. So when you pass the .index, say nums.index, okay, when you pass this particular method on a list, what it does is that it's going to return the index of a particular number, the number that you put here. So if I say the nums.index2, it means that it's going to look through this particular list and now return the index of this number. So this is 0 and 1. That means that when I do nums.index of 2, it's going to return what? 2 is going to return 1 for me, because 1 is the index of 2. I hope you understand that. It's going to return 1 because 1 is the index of 2. But then if I enter a number that doesn't exist in my list, so say 8 doesn't exist in my list, it's going to give me a value error. So this is one thing we should know, that when there is the right number, when the number exists, it's going to give me the index of the number. But if the number doesn't exist, then it's going to throw an error. Once I'm aware that it's going to throw an error, then I have to guard against that error, because as soon as there is an error, my whole program is going to stop. And I don't want it that way, because it could be that the number, the expected value that I got here is not available in my list and I need to continue. Okay, so in Python, we use the try and except block to catch some of these errors. So I'll say try, then what am I trying? I want to see if the index exists. Nums.index, then I pass the expected value. This is going to help me retain the index if it exists. Okay, so I can probably pass this to a variable called expected index. Then I say this is equal to that. Then all I'm going to do now is return the expected index, and the I, because I is also an index. But then I need to catch that exception. What if that doesn't happen? I mentioned that it will give us value error if the index doesn't exist. So I'll go ahead and say continue. I don't need my code to stop. I need you to continue because I'm still looking for the solution and I'm yet to find it. All right, this is a very good solution. It's going to solve the problem, but there is a condition that it doesn't meet. So for now, let me just go back, send the code back to what we had initially. Then let's use the two of them. So I'll print an empty space between them with the help of just a print statement. Then I'll print with the pro. Is that not how I call it? Sums pro. Sorry. So this one was called Sums pro. Okay. So if everything works right, I expect that the two of them will give me the same outcome. Let me clear my terminal, clear the terminal, run this code. And you see, okay, so the order doesn't matter. That is one thing that we're told. Otherwise, I would have to change. If the order matters, then I have to pay attention that I was put before J. So just to make sure that they are all working the same way, let me put I here. Okay, good. So now clear the screen, run the code again. Then we have 1 and 2. So this code is working. You may say that it is working perfectly, but as I mentioned earlier, you'd have to try out the code multiple times to know that everything works the way you want it to work. Then now we are getting the same thing, but remember that when we're starting to, I mentioned that you pay attention to the conditions that you were given. So with regards to the conditions that we were given, we said we shouldn't use the same number multiple times. Let's assume that this was 8, okay, and this was 5. Since you know that 4 plus 4 is 8, but then 5 plus 3 is also 8, and we've been told not to use 4 multiple times because we have used it. Once you use it, you can't use it again. So our answer cannot be 0, 0. So it can't be 4 plus 4. So let's run this. And as you can see, the first code is giving us index 1 and index 3, which is the right answer. But the second one is giving us 0 and 0. Why is that so? The first one, we checked for something here with the help of this range. Because I put this, if I eliminate I plus 1 from here, then at the end of the day, we are going to get the same thing, 0, 0, which is wrong. So the I plus 1 here that I put as the starting point, I said if we have dealt with you, I don't need you any longer. Let's move on to the next one. That was why we had the I plus 1 here, and that prevents that from occurring. In this particular code, with regards to the index method, the index method takes some optional value where we can tell it to where to begin counting the index. All right, so once we are aware that we have used this particular index, then we want to start from where I plus 1. Okay, so it's similar to the range function, except that here we put it after the value. Okay, so I plus 1. And now when I run this code, it should give me the right answer, which is the 5 and 3. Okay, 5 and 3. And if you try out multiple of them, you are going to still get the same answer. So basically, that is how I go through solving a problem like this, the thought process and everything. I'm going to push this code to GitHub and link in the description below. So if you need it, you can always reach out to check it out. Thank you for watching, and I'll see you in the next video. Bye-bye.